Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 5, Section 1, titled Comparing and Ordering Fractions. By the end of this section, you'll have reviewed the procedures for comparing and ordering fractions. This will include finding the least common multiple by using prime factorization. Additionally, you will compare fractions using a number line. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them, and I do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's get into it. Objective 1. Finding the least common multiple. Before you can compare fractions, you must convert each being compared to a common denominator form. This may be done most easily if you just multiply the dissimilar denominators together and then do your cross multiplication of the numerators. However, in practice, this method can be more difficult when it comes to simplifying the resulting fractions. Often the best method to use is obtained by finding the least common multiple, or the LCM, and then doing the cross multiplication. In definition, the multiple of any non-zero number is the product of that number and any non-zero whole number. For example, let's look at a few here. Multiples of 4. Multiples of 4. Right here is the 4. Multiples of 4. 4, 8, 12, 16, 24, 20, 24, 28, 32, 36, 40. All multiples of 4. How about multiples of 6? 6, 12, 18, 24, 30, and so on. As you see here, the common multiples are the multiples that I've colored in red and green. These are the common multiples. So that's, in this case, we'll call common ones 12, 24, 36, so on. But note that the least common multiple is 12. None below either of those are common. There are multiples, but they're not common. The most common one is 12, and then 24, and then 36s. Okay? Okay, example 1, a real-world problem. The method of finding the least common multiple may be used to determine the coincidence of two events that happen at different rates will coincide with each other. The example in the book talks about the baseball team and the soccer team having different playing schedules. The baseball team having a 6-day play schedule and the soccer team playing every 5 days. To find out how often the teams will both be playing on the same day, they employ the method of finding the least common multiple of the play schedule. So the question is, when will both teams be playing on the same day? If you look at the list, if we list it out and we say right here that the baseball team playing every 6 days, they will have the multiples are 6, 12, 18, 24, 30, and so on. I think it's supposed to be 36 probably was missing there. List the multiples of 5s. You get 5, 10, 15, 20, 25, 30. Okay. So here it can be seen that the LCM is 30, the least common multiple. So in 30 days, the two teams will again be playing on the same day. And you can see 30 is there are no common multiples below 30. So that's it. Every 30 days, those teams will coincide on the same day. Okay, example 1, checking your understanding. So as you see here, they want us to find the least common multiples of these listed numbers. 3 and 4 in problem A, 4 and 5 in problem B, and 3, 4, and 5 in problem C. So why don't you go ahead and stop the video and try them out and try them on your own, and then when you get done, come on back and we'll do them together. Okay, I'm assuming now that you've stopped the video, if you intended to, and we're ready to get doing them together, so let's get started. So for problem A, we have 3 and 4, so we're going to start with 3. And if we start with 3, what are we going to say? We're going to say 3, right? 6, 9, 12, 15, 18, 21, 24, 27. Let's see if that's far enough. We'll see. Hopefully it's far enough. For 4, we have 4, 8, 12, 16, 20. Right? So far we're going 24, 28, 32, 36. Are any of these common? So if we look now, we'll see that we've come up with a set of common multiples. And those common multiples are here, are 24, right here. Those are common. And below that, we have 12. Let me use my pen, it's easier. We have 12s. Here's 12s. And 12 and 24, they doubled, right? So we kind of know for sure. There's no more in here. 15, 16, 18, 21. So the least common multiples are going to be what? Are going to be, the least common multiple in this case is going to be 12 is the LCM. Okay, let's do the next one. So now we know what we have 4s here. We don't have to write them if we don't want to. We can go ahead and write the, if we would like, we can write just the 5s out. So on this one, we can do 5, 10, 15, 20, 25, 30, 35, 40. Okay, let's see if that's enough. We need to get something ending in a 5, and 4 and 5, right? So we have 20 ends in a 0 or a 5. So 20 is probably going to, here's 20. So I'll go back and get a red now. So 20 is common. 20 is common here and here. 20 right here. The 20 is right there. Right there. So 20 is the least common. Nothing below that fits. We have a 15 here, and but that's on the 3, but not on the 20. So 20 is our LCM here. Now how about 3, 4, and 5? So we have the numbers for 3 and 4, so, and the 5's over here. So if we look at them together, we can say that we had, where are they common? 12, so it has to be above 24. It looks like 20, 25, 30. 3 is going to give us 30, and we didn't have a 30, so 30 doesn't work. 35, we're not going to get a 35 here. 40, 3 does not give us 40. So we're going to have to go up even higher and do that. So maybe we might need to go across the whole bottom here. Let me 1 second here. Okay, let's go ahead and just write it out. We'll start. We have a big space to write it in, so let's give it a try. Let's start with. Let's just do the 5. So we got 5, 10, 15, 20, 25. 30, 35, 40, 45, 50, 55, 55, sorry, and 60, 65. So 60. Does 4 go into 60? Yeah, 60 will go into there. That'll be a 15. 3 goes into 60, 20. So I think we found it because none of these others are divisible by 3 and 4 together. So if we're going to run these out, we're going to have the LCM is going to be 60. I'm going to change this back to blue. 60 is going to be common because we can take the 4. We'll start it for the 4s. We'll start at 36 and go to 40. Okay. 40 worked here, but there's no 40 with the 3. 40, and since we're doing 4s, 44, 48, 52, 56, and 60. Voila, 60. For the 3s, we have, let's start up here at 27. We're going to get a lot of them. 27, right? 30. No 30s on the 4, so it didn't work. 30, 33, 36, 39, 42, 45, 48, 51, 54, 50, excuse me, 57, had a brain fog for a second there, and 60. So here is 60, 60, and 60. So the answer is the 60 is the LCM. equals 60. Okay, there's our answer for that problem. Okay, so as we're moving through this, we've got a definition of a prime number to look at. So the definition, a prime number, or a prime, is a natural number greater than 1 that has no positive divisors other than 1 in itself. The quantity of prime numbers is infinite. However, in our example, we are presented with only the starting 20 prime numbers. Prime numbers, here they are: 2, 3, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 73, 79, and it goes on and on forever. If you want to see a larger list, you can see 1,000 of them listed in Wikipedia under a list of prime numbers. But they're very important numbers, and it wouldn't hurt if you would spend some time at least thinking of the first 6 or 7 of them: 2, 3, 7, 11, 13, 17, 19, 23. Just read those over, memorize them a little bit in your head, just get familiarize yourself with them. Because you'll be using them in the future. And 2, 3, 7, 11, 13s, they come up, 17, they come up all the time in your math classes. So anyways, good luck on that. Example 2, using prime factorization. Using prime factorization is another method of finding the LCM of 2 or more fractions. Prime factorization occurs on a number when you break the number down into a list of prime numbers. Thus, its prime factors. Prime numbers are numbers that can only be factored into 2 numbers, itself and 1. Once all the primes are found and the greatest factor of the non-occurring primes are multiplied together, the resulting product of this multiplication is the LCM of the full set of denominators of the problem. So let's try one. Let's look at it. It says, let's try one here. Find the LCM of 12 and 40 using prime factorization. So right here, we're 12 and 40. Those are our 2 numbers. Start by listing the numbers to be factored and then factoring out the 2's if the numbers are even. And if not, then you're going to find out what the next lowest LCM is. But I'd start with 3, then would be the next one. But in this case, we're going to start with 2. So when we start with 12, the first thing we do is get all the 2 factors out. So 12 divided by 2, 6. So those are 2 and 6 are factors. Now we have a 2 as a factor. Now we have the 6. The 6 right here, we break it down into factors. Well, we have a 2 and a 3. Okay, so can these be factored any further? No. 2 is a prime number. 3 is a prime number. And as you remember on the earlier slide, I said it would help to memorize these, or at least remember them. 2, 3s, 5s, 7s, 11s, those are all good to remember, those numbers. So on the 40, we can take the 40 and break it into 2 factors. A 2, because we wanted to start with the 2, and a 20. And now we can take the 20 and break it into 2 and 10. And then we can take the 10 and break it into 2 and 5. So these are all the prime. 2, 2, 2, 5. And on the 12 over here for 12, it's 2, 2, and 3. So what this tells us to do up top here is to take the highest occurring factor in the number, those factors, and multiply them together. And what does that mean? Well, if we look at the 12, there are 2 2's. So that is 2 that's 2 squared, right? 2 squared. But on 40, there are 1, 2, 3 2's. So that's 2 cubed. So that right there, the 2 cubed is higher than the 2 squared. So we're going to use the 2 cubed in this case. And there's only 3's. There's only 1 3. It's the highest occurring one is one of them. And there's only 1 5. So that's the highest occurring factor. So we have the numbers we're going to deal with here are 2 cubed, 3, and 5. Those are the numbers we're going to multiply together. And if you do that, for the LCM down here, we're going to see that we have a 2 times 2 times 2. 2 times 2 times 2, that's the 2 cubed, times 5, that's here, right here's the 5, times 3, and that's the 3 over here. You multiply those together, and you get 120. As you see it here, 2 cubed times 5 times 3 is 120. So that's our least common factor. We found it by just breaking it into primes and taking the highest occurring prime factorization count in both sets of numbers and multiplying them together. And then what does it look like with a problem here? So let's pick, we have a 12 and a 40. We'll pick a 3. 3/12 minus 3/40 right here. 3/12 minus 3/40. So how do we make it work? Well, we take the denominator we know is going to be 120. It's right here. We know it's going to be 120 because we wanted it to be. We found it right here at 120. But the numerator is we're going to take the numerator, the 3, right here, 3. We're going to multiply it by the new denominator, 120, and then we're going to divide it by the denominator that was existing. So in other words, it's 3/12. If you look at it that way, it's 3/12 times 120 minus 3/40 times 120. And that equals, what will that equal? So that's going to equal, as we break this down, the 12 is going to go into the 120 10 times. 10 times, that's this right here. We see it now. Here's these same things we wrote here. 10, so now when we're done, when we do this multiplication and division, we're going to end up with 3 times 10. So that's the 12 going into 120. 3 times 10. That didn't look like a very good 3. Let's try that again. 3 times 10 minus 40 goes into 120 3 times. 3 times 3 is 9, minus 3 times 3. And then that equals 30 minus 9 equals 21. Well, that's what we're going to get here. We get the 30, right here, 30 minus the 9, and it gives us a 21 1/20. Right here, 21 1/20. So that's the answer to this problem. Okay, example 2, checking your understanding. Find the LCM of the following prime factorizations. So we're going to do these problems one at a time. You can stop the video as we do each problem and try it on your own, or try to do all 3 of them at once and come back. However you want to do it, it's up to you. You're in control on your end. But you can go ahead and stop the video, and when you restart it, we'll go ahead and get started. So, okay, now that we're back, we're going to start over here with problem A, and we've got a 6. And the 6 can be divided into a 2 and a 3. So there's our factorization for that number. And we have a 16. And 16 is even, so we can divide that by a 2. There's a prime number for it. And we have an 8. And the 8 can be divided into a 2 and 4. And the 4 can be divided into 2 and 2. 1, 2, 3, 4 2s. 2 to the 4th. We have a 2 over here, which we can cancel, and we have a 3. So this is 2 to the 4th times 3, and 2 to the 4th times 3 is, 2 to the 4th is 16. We know what it is. These are all 2s. 2 to the 4th times 3 is 48. The LCM is equal to 48. How about this one? You can stop when you're back. Okay, you're back. Okay. 9 breaks into a 3 and a 3. We didn't try with the 2 because we know 9's not even, so we started right away with the 3's, our next best prime number. And now we have 15. So what do we do here? We take, it's even, not even, so we're going to start with the 3, and yes, 3 does work. 3 and a 5. That's 15. So what does this give us? It gives us 3 squared, and this 3 then is no good to us, plus the 5. So we have times 5. So 9 times 5 is equal to 45. So our LCM is equal to 45. How about this one? There's 3 numbers. Let's try these. 12, they're even. 18 is even. 15 is odd. So we're going to start. Let me clear up my little mistake here. And that one too. Sorry for bumping into the palette. So we're going to start with a 12. And the 12 breaks into a 2 and a 6 and the 6 breaks into a 2 and a 3. I love doing these. They're fast. Okay, 15. You break the 15. 15 breaks into a 3 and a 5. Those are all prime numbers. And the 18 breaks into a 2 and a 9, and the 9 breaks into a 3 and a 3. So here we have 3 squared. Here we have 2 squared. And we have a 3, which it's only a 3 to the first, so we don't use it. Here's a 3 to the first, we don't use it. And we have a 5, it's nowhere else, so we use it. And we have the 5. So it's 2 squared times 5 times 3 squared. And if we look at that, it's 4 times 5 times 9. And that equals what? 4 times 5 is 20. Oh, excuse me, 20. And 20 times 9 is equal to 180. So the LCM is equal to 180. Okay? Good deal. Okay, example 3, finding the LCM of variable expressions. Finding the LCM of a variable expressions is the same as that for natural numbers. First, break the expression into coefficients and variables, and then factor each accordingly. Well, we're going to find out here that in terms of our variables, we only have A's. There's not A's and B's and C's and D's. So this is going to be easy because there's only A's. And we're going to treat these A's as if they're prime numbers. So right off the bat, the A's, A squared here, A cubed here. So there's nothing really to break down, just be A, or 2 A's over here. So we're just going to leave them. On this side, A squared, and on this side, A cubed. But what we can break down are the numbers, the 6 and the 18. So we're going to start with the 6. And as we know, the 6 breaks into a 2 and a 3. Those are the primes for 6. And then there's also the A squared, and I'll just bring down the A squared down here, okay? Make that A squared. It's kind of rough looking. Now, in this one, we have the 18, A cubed, and that's going to break into 2 times 9, and 9 is 3 times 3. So here we have 2 3's, and we have a single 3 over here. So this 3 is going to be canceled. This is going to be 3 squared. This 2 is canceled or used either one because we have a single 2 here and a singular 2 here. So we're going to use one of them. It doesn't matter which one we use. We'll go ahead and just cancel this. I can cancel that. And we use this 2. So 2 times 3 squared. And we have A squared here and A cubed here. Well, the largest number we have is the A cubed. There's 3 A's here, 2 here. So these are going to cancel. And we use the A cubed. So we're going to have A cubed. And when we solve this, it's going to be 2 times 9. Oh, yes, 2 times 9 is 18 A cubed. That is our LCM. LCM is equal to 18 A cubed. Okay, example 3, check your understanding. As in the past, go ahead and stop the video and work these on your own to see how you work out. And when you come back, we'll do them together. So now that you're back, let's start with A. It says find the LCM of 12x and 15xy. And if you recall in the earlier slide, I said to treat the variables as if they're prime numbers because you can't split them in any way. There's no way to factor them. The only thing you can factor is the coefficients. So you have to treat the variables as primes. And therefore, if there's a square or a cube or whatever, then that's it. Whatever it is what it is. You don't have to manipulate it. So we're going to start off with 12x. Okay? And 12x breaks into 2 and 6. And the 6 breaks into 2 and 3. And so that gives us a 2 squared and a 3 and an x. So it's 2 squared times 3 times x. The 15xy gives us 3 and a 5. Those are the primes we get there, and we get the x and a y. There's an x here and an x here, so one of them can cancel. I'll cancel that one because they're the same. They're both to the first power, so you can only pick one of them. And then we have a singular y here. So the whole answer is going to be 2 squared. 2 squared. We have a 3 here and a 3 here. We can only use one of them, so might as well use this one here. So we have a 2 cubed. 2 cubed. What, I'm writing wild numbers here. Come on. 2 squared. Sorry. 2 squared times 3 times 5 x. There's only a singular power on x, so it's x, y. So what do we get here? We get 4 times 3 is 12, times 5 is 60, x, y. So the answer here would be 60, x, y. That's our LCM. Let's go to this one. The LCM for 8m squared. So here's where we can say that m is already a prime number that's squared. So there's 2 m's. So 8 breaks into 2 and 4, and the 4 breaks into 2 and 2. So that's 2 cubed m squared. And this 14 is 2 and a 7. And there's another one of them prime numbers, 7. And m to the 4th. 2 times 7 times m to the 4th. Okay, so now that m to the 4th beats the m squared, so that m squared's gone. There's a 2 cubed. There's a single 2 here. This 2's gone. There's no 7 anywhere else. So all we have is 2 cubed, and a 7 times 7 and times m to the 4th. And that is equal to 2 cubed is 8 times 7 is 56. M to the 4th. That's our LCM. Okay, let's do this over here. Find the LCM. 25y squared. 25y squared. And 25 breaks into 5 and 5, which is 5 squared. And we have a y squared. There's nothing to do with it. Nothing more you can do with it. And as far as the the 15, 15x breaks into 3 and a 5. Those are primes, and x is its own prime. So we have 5s over on this side, so this single 5 over here is going to cancel. There are no 3s on the side with the 25, y squared. So we're going to use the 3, and we're going to use the y squared, and we're going to use the x. So the answer is going to be, what is it? We got 5 squared right here, y squared, and x. And the 3. 3y squared, 5 squared, y squared. And when we multiply that out, so you see we got the 3 here. Here's our 3. Our 5 squared is here. And our y squared. So 25 times 3 is 75. And we have a y squared and an x. Oftentimes, they like you to put the x first. In fact, let me rewrite it that way. It doesn't have to be that way, but I'm going to do it anyway. Maybe I like it. X, y squared. Okay, that's our LCM. Okay, objective 2, using a number line. It's also possible to compare and order fractions using a number line. The number line can be useful if you'd like to see the fractions organized in a way that allows you to picture the comparison. For instance, for the question, is 1/2 larger than 1/4? Placing them on the number line will help to make it very clear, as the larger numbers are found to the right of the smaller numbers. So let's give it a shot. We'll give it a try. We'll pick in the middle here. Let's pick this spot right here, and we're going to call it 0. You can do that anywhere you want. And I'm going to say every one of these tick marks is a quarter. So 1, 2, 3, 4 ticks. Now we're at 1. 1, 2, 3, 4 ticks. We're at 2. And then we went 1, 2, 3, 4 ticks. We'd be at -1 or -1, right? So now what we're going to do is we're going to put a half and a quarter on the number line. Well, the half, let me change colors here. The half is, these are quarters, so here's half right here. So I'll put the half up here. This is your half, 1/2. And I'll use blue. And here's 1/4, 1/4. So, since, as it says here, the larger numbers are to the right of the smaller numbers, and we're going to the right in this direction here, the half is farther to the right than the quarter. So the half is absolutely larger than the quarter. Now, if this was reversed, if we called this -1/2 and -1/4, what would happen? Well, let's make it 1.5 and 1.25 to move them down the line here. But 1 and -1.5 would have been way down here. This would have been -1 and 1/2. Okay? And down here would be -1 and 1/4. This here would be -1 and 1/4. Okay? So here's -1 1/4. I'll make this one here. I'll make that one, this one here, the 1/2. And now what's to the right? Well, it's a negative number. So now the 1 1/4 is to the right of the 1/2. So that means that the -1 1/4 is larger than the -1 1/2. Okay, example 4. Using a number line. So what they want us to do here is to graph and compare a couple of fractions and see how they come out. So let's take a look at it. So it says 9/11 and 6/11. They want to know which is larger, which is smaller. So we're dealing with 11 in the denominator, so I have a bunch of ticks. So let's start over here to the left-hand side so that we have room to work to the right, because these are positive numbers. So if we start with our 0 right here, and then see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? This is 11 right here. I'm having a hard time today. Literally writing. I'm not sure what's going on here. 11ths. There we go. So, and if that would be like to start over again, right? So this is 11. So we have an idea. So if we were to start here at 0, we go 1, 2, 3, 4, 5, 6. 6 11ths. And 1, 2, 3, we're 5, 7, 8, 9 11ths. You can see right here that 6 11ths is to the left of the 9 11ths. Okay, here's 11 pieces. So 6 11ths is less than 9 11ths. And let's try this other one. So this is tenths we're going to deal in, and a half. So they're going to have, these are different. But we know that in half, there's how many tenths? 10 can be divided by 2, right? So, and get 2 5s, which are the halves. So we're going to start over here on this side this time, and this is going to be our 0. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Although this time, I'm going to call this one 1. Okay? I didn't do that here on the 11ths, because it was kind of an odd number, but this is now 1. So that means that this is 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. So 5/10 is right here. Okay, I'm going to say 0.5 because this is negative 1 and this is negative 0.5. So 6, 7, 8, 9, 10. So, okay, so this is negative 1/2. Okay, this is negative 0.5, 1/2. So they want to know, is 1/2 negative 1/2? Here's negative 1/2, and here's negative 1/10. Well, here's 1/10 right here. Negative 0.1. Right here, negative 0.1. The negative 0.1 is to the left, to the right of negative 0.5. So that means that negative 0.5 is less than negative 0.1. Or since they did that as a half, I could also say negative 1/2 is less than negative 1/10. Okay? Okay, for example, under check your understanding, we're going to, we have 3 problems. And as usual, go ahead and stop the video and try these on your own. And when you start the video up, we'll continue on and we'll work them together. So now that you've had time and you're back, let's take a look at them. The first one says 4/9 and 2/9. Which one is greater? Or we can write it as a greater than or equal, that kind of greater than inequality. So 4/9, so let's break this into ninths. So, and these are all positive numbers, so I'm going to start the 0 down here further. So this is 0. And 1, 2, 3, 4, 5, 6, 7, 8, 9 right there would be where we'd stop. That would 9 right here is 9 for the ninths. If we were going to 1, this would be our 1 right here, right? So we're going to start here at ninths. All of these are ninths in here, and we have 4/9. 1, 2, 3, 4. Here's the 4/9, and here's the 9/9 right here. Okay, 9/9. So what's greater, the 9/9 or the 4? Oh no, not 4/9 and 2/9. I'm sorry. Please forgive me. 4/9 here and 2/9. 1, 2. I'll mark it down on the bottom. 2/9. So what's greater? The number to the right is more positive than the number to the left. So the 4/9, I'll write it up here. 4/9 is greater than 2/9. Okay? Now here we're the same numbers, only negative. I'll put the 0 over here. And we're going to go negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's negative 9. And so this is 9, and there are 9 of these. These are all ninths. Okay? So it says negative 4/9. So here's 0, 1, 2, 3, 4. Here's negative 4/9, negative 4/9. And here's negative 2/9. 1, 2, down here. Negative 2/9. Which one is more positive? The number to the right. And the negative 2/9 is more to the right than the 4/9. So that means that we can write it negative 4/9 is less than negative 2/9. See how the sign switched when we changed sign from positive to negative? This is now negative, greater than, this is less than. Over here, 4/9 and 2/9. So, well, it doesn't matter where I put the 0. I'm going to put the 0 here, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's our 9 negative, and 1, 2, 3, 4, 5, 6, 7, 8. Well, 9's out here. It doesn't really matter. 1, 2, and it wants 2 now. So 1, 2. So here's 2/9, positive, and here is 4/9. 1, 2, 3, 4/9, negative. So the number to the right is greater than the number to the left. So the 2 is greater than negative 4. So we're going to say negative 4 is less than 2. Or you could write it the other way. You could say 2 is greater than negative 4, however you choose to write that. Okay?